Okay, so we are going to run through a future withdrawal program that does what this description shows. It says it finds the future value of an initial investment where fixed withdrawals are made at the beginning of year 2. And the inputs are the initial investment, the APR, and this time we're going to do it as a percent, and the fixed yearly withdrawal, which starts at the beginning of year 2. And the outputs are going to be the yearly balance for 10 years at the end of each year. Okay, so the starting point is the future value program that's in Chapter 2. That doesn't do quite what we want, though. This one computes the future value of an investment, or a principal is what they use, is the terminology they use here, where you just plunk your money down and you get the bank interest rate compounded for 10 years. And the way the print statement is set up here outside of the for loop, only one print is executed at the end of the for loop, and so you only get your amount after 10 years. So what we want to do is do this year by year. Alright, so let's just take an example here. Let's say we had to do a pencil and paper type of a thing. Let's say you had $10,000. That was your initial investment. And you had 5% APR, and you took out $1,000 every year, excuse me. So at the end of year 1, what you would have would be $10,000 times 1.05. And so if you grab your calculator and you do that calculation, I'm doing this as we speak here just to make sure I get it right. $10,000 times 1.05 is $10,500. That takes us to the end of year 1. No 0 on the end there. Okay, so at the end of year 2, what you're going to have is you're going to have $10,500, which is what you started with in year 2, minus the $1,000 withdrawal that you make, times 1.05, because that's the interest you're earning. So that shows you the pattern. Okay, so let's go over now and look at the future withdrawal program, which I wrote. I didn't want to make this a really long video and do this while you watched. So essentially, if you look through the program here, I asked the user to enter the initial investment. That would be the $10,000 in the example that we just did. And I asked for the APR as an interest rate. And so if we're doing a 5% rate, they would actually enter 5, not 0.05. And then I asked for the withdrawal, which will start in year 2, at the beginning of year 2. And before going into the loop, I do two things. I define a factor, which is 1 plus the APR divided by 100. So I can just multiply by factor to get my compounding. So in the example just done, this would be 5. 5 divided by 100 would be 0.05, and the factor would be 1 plus 0.05. And then the balance at the end of the first year is going to be the initial investment, which we've prompted and gotten from the user, times this factor. Okay, so now I go into my for loop. And the first thing I do is I define a variable y, which takes the I generated from the range statement and increments it by 1, so that I get year 1. And so I'm going to print out y. So here I'm using that same format statement I showed you before. You don't need to format an integer, so I can just put y in there like this, and then I can put $balance 2f here to get 2 decimal points. And then after I print it out, then I calculate what the balance is going to be at the end of the subsequent year. And so that is simply going to be the, the balance minus with the withdrawal. Remember the calculation we did early on, the handwritten calculation. So that's going to, of course, bring the balance down. But then that balance is multiplied by a factor of 1.05 if 5% is the interest rate to get you the interest increase at the end of the year. Okay, so let's run this, and actually I already have the output over in the Python shell. This is the output right here. So you can see what I've done is the same thing that the example that I used. So here's the $10,000, and here's the 5% rate, and here's the $1,000 withdrawal, and here you see 10,500, and my decimals aren't working here. I think I know why, but that doesn't really matter all that much for this example. And then 9975 should then now compare with what I did here. And so this should be 9975, and if you calculate this out, you'll see that that's what you get. So here's the output, and it shows you that if you do this, you can do this for 10 years. Actually, this I ran for 20. You can do this for 10 years and still have $4,700 left. But if you keep on doing it for longer, you have to change some parameters in the program to do this. You'll draw it down until in year 15 you have $210 left, and in year 16 you won't be able to draw $1,000 anymore. So there you go.